Hello my friends and welcome back to the You Can Do TV channel. Rody Construction carried out a fast-track revamping of a continuous casting machine, CCM, beginning with detailed design and planning to minimize downtime and ensure seamless execution. The project started with the demolition of obsolete foundations, using precision cutting and controlled removal techniques to avoid interference with surrounding equipment. Following demolition, reinforced concrete works were executed on a compressed schedule, with rapid curing compounds and high-strength mixes to meet load-bearing and anchoring requirements within tight timelines. A critical part of the upgrade involved the installation of prefabricated foundation modules, designed off-site for dimensional accuracy and faster assembly. These modules included embedded plates and pre-installed conduit systems to accommodate the CCM's mechanical and electrical interfaces. Using advanced rigging systems and laser alignment tools, the foundation blocks were positioned with millimetric precision. Once set, anchor bolts and load transfer components were grouted and torqued to specification. The modular approach allowed parallel installation of utilities and minimized on-site labor congestion. Rody's coordinated execution ensured structural readiness for equipment mounting, aligning with the accelerated commissioning schedule. The result? A stable, high-precision base supporting the upgraded casting system's long-term performance. Rody Construction completed the ThyssenKrupp revamping project, using advanced fast-track techniques focused on engineering precision, structural performance, and rapid execution. A total of 320 pre-assembled foundation blocks were produced off-site, each designed with strict XYZ coordinate tolerances to ensure seamless on-site integration. These blocks, ranging from 45 to 95 tons, were engineered to interface precisely with critical equipment loads, minimizing field adjustments. Demolition involved the removal of 9,000 cubic meters, 12,000 YD cubed, of reinforced concrete, including foundation cuts down to 8 meters, 26 feet. High-precision cutting technologies and controlled sequencing ensured safety and efficiency in confined industrial spaces. The new foundation works included 8,000 cubic meters, 11,000 YD cubed, of high-strength, fast-curing concrete, poured in phases to support heavy equipment such as rollerways and shear lines. The installation of precast walls and Peco column systems allowed for rapid vertical structure assembly with integrated connection detailing. Rody's use of laser alignment, 3D surveying, and modular lifting plans ensured accurate placement and load transfer. A 120-person crew, working in continuous 24/7 shifts, coordinated structural, mechanical, and civil interfaces to meet the 35-day deadline, demonstrating Rody's capability in delivering complex foundation systems under extreme time constraints. Rody Construction carried out a fast-track revamping of the intermediate mill at Alpha ACCIAI, combining high-precision civil engineering, off-site prefabrication, and real-time coordination. The project was driven by a 3D BIM modeling system, which enabled detailed planning of all structural elements, clash detection, and alignment of prefabricated blocks with existing infrastructure. Before the shutdown, Rody completed the prefabrication of critical concrete blocks and initiated piling activities, which continued during the shutdown. This allowed overlap of work phases and significant time savings. In Phase 1, lasting 12 calendar days, the team executed 2,500 cubic meters of demolition and excavation. A 7.00-meter-deep micropile wall was installed to support the structure, followed by the casting of 1,000 cubic meters of reinforced concrete, including 500 square meters of floor slab. These structural components were designed to bear loads of up to 20 tons. Phase 2, lasting 14 calendar days, included an additional 3,000 cubic meters of demolition and excavation and the construction of a 6.70-meter micropile wall designed for 12-ton loads. In a tightly controlled 12-hour operation, 14 prefabricated concrete blocks were precisely positioned using crane-assisted handling and laser alignment systems. The total volume of reinforced concrete installed reached 3,000 cubic meters across both phases. Rody maintained continuous work cycles, coordinating up to 3 shifts per day to ensure completion within strict deadlines. This project is a clear example of Rody's ability to manage complex industrial revamping under pressure, leveraging modular construction, technical precision, and integrated scheduling to minimize downtime and deliver long-term structural performance for one of Italy's leading steel producers. Rody Construction's fast-track revamping method allows complete plant upgrades with minimal downtime, reducing execution time by up to 75%. The process consists of 3 phases. First, engineering and planning is conducted to assess feasibility and design pre-assembled foundation modules. Next, in off-site prefabrication, these modules are built while the existing plant remains active. Finally, during the on-site work phase, old foundations are demolished, and the new concrete structures installed rapidly during a short shutdown. This approach ensures speed, precision, and continuity, enabling plant transformation without disrupting nearby operations or long halts in production. As part of a major road infrastructure upgrade in Tinlot, Belgium, the demolition of the bridge at the N60-N63 interchange was a critical phase, requiring precise planning and rapid execution. The project aimed to replace the outdated structure to improve traffic flow and safety along this strategic regional corridor. To minimize disruption, the operation was conducted overnight and during weekends, under full road closures. The existing bridge, composed of reinforced concrete beams and deck slabs, was demolished using high-capacity hydraulic excavators equipped with crushers, shears, and breakers. Demolition progressed in sequential stages to ensure structural control and worker safety. Once the deck was removed, heavy machinery carefully dismantled abutments and piers, while trucks continuously evacuated rubble to nearby recycling facilities. Protective measures such as ground mats, debris screens, and dust suppression systems were deployed to protect surrounding areas and traffic zones below. The entire demolition was completed within a narrow time frame, clearing the way for the construction of a new overpass with modern load-bearing capacity and safety standards. The successful operation highlights the coordination between civil engineers, demolition experts, and local authorities in executing complex infrastructure removal under time-sensitive conditions. In summer 2015, Zurich carried out one of its most ambitious public transport infrastructure projects at the Bellevue Platz, the city's most frequented transit hub. With over 75,000 passengers and 60,000 vehicles passing daily, Bellevue and the nearby Quaybrook were completely rebuilt to modernize the tram network and enhance long-term performance. The project involved removing the entire existing track system and replacing it with 1,750 meters of new rails, 19 switches, 4 rail extraction points, and 3 automatic rail lubrication systems. Over 3,500 cubic meters of demolition material were cleared, followed by the application of 800 cubic meters of recycled gravel and 1,600 cubic meters of new concrete. Work was concentrated into 2 critical weekends in July, with over 400 personnel on-site working around the clock. The first weekend, July 11 to 12, saw intensive removal of worn tracks and substructure, while new track sections were simultaneously laid using pre-planned staging. The second weekend focused on system integration and final concrete works. Due to space and weight limitations on the Quaybrook, heavy equipment could not be used, requiring light demolition tools to break old track beds. Below ground, old foundations were excavated, replaced with compacted layers, and separated by geotextile membranes to protect soil integrity. Drainage lines, utility shafts, and technical ducting were installed in parallel. Platform edges were rebuilt and adjusted to meet accessibility standards, while 2 new shelters, in the style of the historic rotunda, were constructed. Welding crews connected 73 track segments, mostly during night hours, ensuring uninterrupted daytime progress. Final trial runs with all rolling stock validated track alignment and switch function. On August 15, the tram system resumed operations. Despite complexity, tight deadlines, and urban constraints, the Bellevue upgrade was completed without delay, setting a benchmark in urban rail renewal. The austere Marina project in Vulyag represents a landmark coastal infrastructure development in Greece, led by TEKA, a prominent construction company. Strategically located on the northeastern edge of the Ester Hotel complex, the project site lies on the eastern shoreline of Vulyag Bay, approximately 25 kilometers from the center of Athens and 24 kilometers from Athens International Airport. The redevelopment initiative was commissioned by Astir Marina Vulyag SA and aimed at modernizing and upgrading the existing marina to meet international standards of luxury and functionality. A defining feature of the construction involved extensive marine engineering works, particularly the placement of 3,470 acropodes. These interlocking concrete armor units were critical to reinforcing the breakwaters and protecting the marina from wave action and coastal erosion. Their installation required precise lifting operations and underwater placement using specialized marine equipment. In parallel, a total of 2,026 precast structural components were fabricated and installed across various elements of the marina, including quay walls, walkways, berthing structures, and foundation systems, ensuring structural integrity and construction efficiency. The project was divided into several key building blocks, each serving a distinct operational purpose. Building Block OT1 functions as the Marina's main administrative hub. It includes a multi-use administration building, with offices for customs and port police, a control tower for vessel traffic management, retail shops, and a fueling station complete with underground storage tanks. The facility is designed with security, accessibility, and streamlined maritime operations in mind. Building Block OT4 addresses crew services and technical operations. It comprises chandlery outlets offering marine supplies, sanitary facilities for crew members, auxiliary service zones, and dedicated storage rooms. These installations support the daily operational needs of the yachts and their personnel and are positioned for direct access from mooring zones. The central component of the Marina's architectural plan is Building Block OT2, a multifunctional facility structured across multiple levels. The basement level houses underground parking areas, warehouse space, mechanical electrical plumbing MEP systems, and electric substations. The ground floor accommodates seafront restaurants, retail spaces, and back-of-house BOH service corridors. The first floor is reserved for additional food and beverage (F&B) venues, providing panoramic views of the bay, along with BOH functions. These structures were built using reinforced concrete and equipped with modern building services to ensure energy efficiency, comfort, and long-term durability. Landscaping was a vital element in integrating the marina into its natural surroundings. The project embraced sustainable design through the use of native plant species and green roof systems, helping to minimize the environmental footprint while enhancing aesthetic appeal. The vegetative roofing systems also provide thermal insulation and rainwater management, contributing to the overall environmental strategy of the development. The entrance channel and first yacht mooring positions were constructed to accommodate large vessels, with high-strength quay edges, mooring bollards, and service connections for water, power, and telecommunications. All utilities were embedded within the quay infrastructure for seamless operation. Through the use of modern construction methods, marine-grade materials, and precision execution, the Astir Marina Redevelopment by TEKALSA has established itself as a premier yachting hub in the Mediterranean, combining technical excellence with architectural refinement. GIPO 131 crusher engineered specifically for Colas, Belgium, a powerful solution built for efficiency and performance. Equipped with a direct drive system, this machine reduces fuel consumption by 50% compared to previous generation crushers. Weighing 73 tons, it's designed for rapid deployment, ready to operate in demanding conditions. The 1.3-meter wide percussion crusher processes material up to 1 meter, powered by a heavy-duty 8.8-ton rotor. A 1.3-ton side magnet ensures clean separation, while the 35-kilowatt high-performance wind shifter optimizes sorting. A 5-meter-long double-deck screen provides adjustable calibration from 10 to 100 millimeters, ensuring consistent, certified granulates. Paired with a calibrated wheel loader, the system achieves an impressive annual production of 250,000 tons. On the E34 highway in Postel, 5 kilometers, and Oud Turnhout, 2 kilometers, Colas Belgium undertook a major rehabilitation project, spanning a total of 7 kilometers. The operation involved the removal of 240,000 square meters of reinforced concrete using an ultrasonic concrete breaker. The broken material was crushed on site and reused, resulting in 39,550 cubic meters of cement-bound foundation type IIA, produced by the on-site Colas concrete plant. In addition, 58,650 cubic meters of in-situ mixed cement subbase foundation was installed. To improve ecological connectivity, 4 eco-tunnels were constructed beneath the E34 to facilitate safe wildlife crossings. Reinforced anchoring ribs were installed over a 13,200 meters section to support a transitional plate. The intermediate and top asphalt layers were applied without longitudinal or transverse joints, ensuring seamless pavement. 2 asphalt finishers worked in parallel across the 13-meter road width, supported by a coordinated asphalt supply system. The high-speed paving process was carefully controlled to maintain material consistency and ensure durability across the entire road structure. This sustainable and efficient approach ensures long-term durability, improved safety, and minimal environmental impact for future road users. The core of the project lies along a 6-kilometer stretch between Overhaul and Nivelles, divided into 2 phases. The first preparatory phase was completed in March, involving vegetation clearance, safety barrier removal, and emergency lane repairs toward Brussels. This €2 million project, commissioned by Sofico, is executed under a tight schedule, 7 days a week. Milling is immediately followed by binder and wearing course application. Despite tight deadlines, teams from Sandpools and Pork supported Colas to ensure progress while maintaining access to exit ramps and the service station as required. Colas Belgium played a key role in the expansion of the industrial zone between Liesel and Giel, a strategic infrastructure project aimed at enhancing regional logistics and supporting economic growth. The project focused on developing road access, constructing new internal road networks, and preparing heavy-duty pavements to support increased freight movement and industrial activity. The works included site preparation, earthworks, and the construction of over 5 kilometers of new roads within the expanded industrial zone. Advanced drainage systems were integrated along the new roads to manage stormwater and prevent flooding. Pedestrian paths, cycling lanes, and access routes were also created to support safe, multimodal mobility. Ground improvement was carried out using lime cement stabilization to ensure a solid foundation for future traffic loads. Colas also installed a cement-bound base layer and a 2-layer asphalt system designed to withstand high axle loads from trucks and heavy machinery. The pre-mixed concrete is spread from a dump truck or concrete mixer, then fed into the paver's hopper. From there, the material is distributed evenly across the working width by an auger or conveyor. The concrete is then spread, compacted, and leveled in a single continuous motion. The machine usually has a scraper or finishing bar at the rear, which ensures that the final layer is smooth, even, and meets the required thickness and slope specifications. Thanks to careful planning, phased execution, and collaboration with local authorities and developers, the project was completed on time and in accordance with environmental standards. SpotFlex is a Type 2 marking system featuring a symmetrical 3D profile that ensures long-term visibility in both nighttime and wet conditions. It is specifically engineered for high-traffic zones, where durability and safety are essential. Applied using Fiberplast structure, this material offers excellent surface adhesion and superior wear resistance. SpotFlex reduces the risk of aquaplaning, enhances tire grip, and provides audible feedback when crossed, improving driver awareness. It also withstands the force of snowplow blades, making it suitable for year-round use. SpotFlex, built for visibility, built for endurance, built for safety. Colas Synefe1 is a major transport infrastructure project in Belgium, undertaken by the Colas Group. The project focuses on the rehabilitation and upgrading of road surfaces, drainage systems, and other ancillary items to enhance traffic safety and extend the life of the infrastructure. During the construction process, Colas uses modern equipment such as recycled scrapers, asphalt pavers, and vibratory rollers to ensure high precision and quality. In addition, temperature and asphalt thickness control technology is applied to increase construction efficiency and minimize traffic disruptions. The project also ensures environmental and occupational safety standards. The Elematic Precast plant installed by BE Villamoria is engineered for high-output, precision-controlled concrete production. Featuring automated casting beds over 120 meters long, the system produces structural elements like slabs, walls, and beams with tight dimensional tolerances. The plant integrates computer-controlled batching, automated reinforcement placement, and curing systems, ensuring consistent quality and strength. Two-deck production lines and fast shuttering setups support rapid cycle times. Logistics are optimized with synchronized tower cranes and track delivery systems. Designed for scalability, the plant supports the annual production of thousands of residential units, while significantly reducing labor dependency and on-site variability through full industrialization. Dubai Precast in the United Arab Emirates operates a highly automated Elematic Precast plant designed for large-scale, high-rise construction. The facility features advanced production lines for hollow-core slabs, solid walls, sandwich panels, columns, and beams. Using Elematic's extruder E9 and fully automated circulation system, the plant ensures precise concrete placement, optimized compaction, and minimal material waste. A centralized batching and mixing unit delivers consistent concrete quality across all components. The system integrates automatic reinforcement cutting and bending, robotic handling, and intelligent curing chambers to accelerate production while maintaining structural integrity. The plant's modular design supports flexible layout configurations, enabling adaptation to complex architectural requirements. With precision control, high output capacity, and integrated logistics, Dubai Precast meets the demanding timelines of urban development projects, while ensuring compliance with international structural and thermal insulation standards for precast concrete elements. Plastic Road is a groundbreaking innovation that tackles two global challenges at once: plastic waste pollution and climate-induced flooding. Made entirely from recycled plastic, this modular road system is lightweight, fast to install, and far more durable than traditional asphalt. Inspired by the simplicity of Lego construction, Plastic Road's interlocking design allows roads to be built in days instead of months. Its hollow core structure acts as a temporary water reservoir, capturing heavy rainfall and gradually releasing it into the subsoil, helping cities cope with extreme weather caused by climate change. These internal cavities also provide easy access for integrated utilities like cables, pipes, and even solar panel modules. Developed by Volker Wessels and Waven, Plastic Road has been successfully piloted in the Netherlands, with 2 functioning bicycle paths in Zwolle and Giethoorn. With over 1 million cyclists already using them, the results prove the system's load-bearing strength, water resilience, and long-term performance. Plastic Road is now ready to scale, offering a circular, climate-adaptive infrastructure solution for the cities of tomorrow. The installation of Geocells represents a crucial step in soil reinforcement and erosion control applications. Geocells are three-dimensional cellular grids formed from high-strength HDPE, high-density polyethylene strips, welded together to create a confinement system. These geocells are used to stabilize weak soil, enhance load-bearing capacity, prevent erosion, and strengthen slopes. Once expanded on-site, the cells are filled with materials such as soil, gravel, crushed stone, or concrete depending on the intended use. A hydraulic plate compactor, such as the Mikasa MVH306DS, is employed to compact the material inside the cells. This machine features advanced hydraulic control, durable frame construction, and a 750 by 550 mm compaction plate. Operating at up to 23 meters per minute, it is ideal for compacting soil. The E19 highway renovation in Merksem, Belgium, is a major infrastructure project aimed at improving traffic flow and safety on one of the region's busiest routes. The works include road surface renewal, bridge rehabilitation, and drainage upgrades. With phased construction and traffic management in place, disruption is minimized. Advanced machinery, including milling and paving units, ensures high-quality asphalt layers and long-term durability. This renovation enhances mobility, supports regional logistics, and meets modern European roadway standards. The demolition of the Chartershall Bridge over the M9 motorway was a precision-engineered overnight operation designed to minimize traffic disruption. Works began promptly at 10 p.m., with full motorway closure in place to ensure safety for both crews and the public. Using a fleet of high-reach demolition excavators, the team dismantled the bridge deck and supporting abutments in carefully controlled phases. Machines equipped with hydraulic breakers and pulverizers broke down the reinforced concrete, while support crews managed debris clearance in real time. Protective measures, including road surface shielding and dust suppression systems, ensured no damage to the motorway infrastructure below. Despite the complexity of the task, all works were completed on schedule, and the M9 was reopened to traffic by 8 a.m., just 10 hours later. The operation showcased efficient coordination, safety-focused planning, and rapid execution under tight time constraints. The Sandvik QS441 is a high-performance mobile cone crusher equipped with the CS440 cone unit. It features hydraulic setting adjustment, overload protection, and ASRE control for optimal performance. Ideal for large feed sizes, it ensures high throughput, consistent product quality, and efficient maintenance planning. Phase 3 of the 2014 Baird Road project focused on milling and repaving worn asphalt surfaces to restore smooth and safe driving conditions. Crews began by cold milling the top layer of pavement to a precise depth, removing deteriorated material. This was followed by the placement of new hot mix asphalt using a paver, ensuring even coverage and proper compaction. Steel drum and pneumatic rollers finalized the surface, achieving optimal density and finish. Traffic flow was restored promptly after curing. Each year, the town of Penfield performs preventative maintenance on about 10% of its 150-mile road network using the oil and stone method. This process, beginning in May, is dependent on weather conditions and equipment availability. Oil and stone is not a substitute for paving but is used to extend pavement life, similar to sealing a residential driveway. The process starts with applying liquid asphalt to seal the surface and fill minor cracks, preventing water infiltration that can damage the road base. Then, a layer of crushed stone is spread to provide a wear surface, increasing traction and improving road safety. In cul-de-sacs, a micro-paving treatment is used instead. The Tensor AX5GN Geocomposite is a high-performance asphalt reinforcement interlayer used to improve the structural integrity of pavement systems. Designed for use in flexible, semi-flexible, and rigid pavements, it significantly enhances fatigue resistance by delaying crack propagation in asphalt overlays. This improvement either extends the life of existing pavements or allows for a reduced asphalt thickness while maintaining the same service life. The product combines a multi-axial polypropylene grid with a non-woven paving fabric, offering multi-directional reinforcement, stress relief, and waterproofing once saturated with bitumen. Installation begins with surface preparation to ensure a clean, smooth base. A bitumen bond coat is then applied, followed by unrolling the AX5GN interlayer. The surface is brushed to eliminate wrinkles and ensure contact. A pneumatic tire roller, PTR, compacts the layer for proper adhesion. Finally, asphalt paving and compaction are carried out using standard equipment. Proper installation is essential to achieve optimal long-term performance. The stone crusher process begins at the quarry, where raw rock is extracted and transported to the crusher. The primary crusher reduces large stones into smaller sizes. These pieces are then sent through secondary and tertiary crushers for further reduction. Screens separate the crushed material by size. Oversized pieces are returned for recrushing. Finally, the desired aggregate is stockpiled as the final product, ready for use in construction, roads, or concrete production. Riley & Sons Asphalt Paving delivers high-quality driveway paving with a methodical and professional approach. The process begins with site clearing and leveling using a front-end loader to remove debris and shape the subgrade. A solid base is prepared, followed by the application of hot mix asphalt. The asphalt is spread evenly and compacted using a steel drum roller and pneumatic tire roller to ensure proper density and surface smoothness. This careful compaction prevents premature cracking and extends the lifespan of the driveway. Riley & Sons combine experienced crews with reliable equipment to ensure a smooth, long-lasting asphalt surface for every project. A driveway peel and pave is a resurfacing method that involves removing the top layer of existing asphalt by wheel loader. The process begins with milling or peeling off the damaged surface using specialized equipment. Next, the area is cleaned and prepared, ensuring proper drainage and subgrade integrity. Fresh asphalt is then applied and evenly spread. Finally, heavy rollers compact the new layer to achieve a smooth, dense, and durable finish. Watering moistens the roadbed, reduces dust, and aids in effective compaction before laying a new layer of asphalt. Excavator. This method restores surface quality, improves curb appeal, and extends driveway life. In road construction, the Caterpillar 14M motor grader plays a crucial role in mixing the base course layer, ensuring a uniform and stable foundation. The 14M's powerful blade control and precision articulation allow operators to evenly blend aggregates, moisture, and fines across the full width of the roadway. This process enhances compaction, load distribution, and long-term pavement durability. With advanced controls and high torque, the 14M delivers smooth, consistent mixing, making it a key asset in building reliable and well-prepared road-base layers. Asphalt is spread evenly using a squeegee or broom for precise application in tight areas. After curing, parking lot line striping and symbols, such as arrows, handicap signs, and parking lines. The Rebel Crusher is a versatile mobile jaw crusher that can crush rock, limestone, granite, brick, block, concrete, and asphalt. It produces 4 products simultaneously, requires no transportation permit, making it the ideal on-site crushing solution. Aquafalt is a cold-mix asphalt patching product that sets with water, even in below freezing temperatures. It contains no petroleum or VOCs, making it eco-friendly. Simple to apply. Just clean the hole, pour Aquafalt, add water, tamp, and it's ready for traffic. The Sandvik UJ540 mobile jaw crusher is a high-capacity tracked unit equipped with the powerful CJ612 jaw crusher. It features a 1,200 by 1,100 mm jaw opening, delivering impressive throughput and a high reduction ratio. Powered by an electric crusher drive, it ensures low fuel consumption and minimal emissions. Hydraulic closed side setting, CSS, allows for fast adjustment of output size. Designed for aggregate production and quarrying, the UJ540 offers easy transport, simplified operation, long service life, and low cost per ton, ensuring high efficiency and performance. At the heart of the Grand Paris Express project, Schindler installed 32 escalators in the Villejuif Gustave Roussy station, lines 14 and 15 south, built 50 meters deep over 9 levels. In Phase 1, 20 escalators were installed in May 2022. Phase 2 followed in April 2023 with 12 additional units handled by 12 technicians. Each escalator was delivered in 2 8-meter sections, assembled and lowered using slings, hoists, and torque-controlled bolts. A major highlight was a monumental 40-meter escalator weighing 30 tons, installed in 3 segments, including a final 18-ton section lifted by a 750-ton crane. The project showcased precise coordination, deep excavation logistics, and advanced heavy equipment handling. Mastless cat grade with 3D for motor graders is a cutting-edge grading solution that eliminates the need for external masts, using fully integrated sensors instead. This enhances blade versatility, reduces setup time, and lowers the risk of mast damage. The system maintains grade accuracy even during wheel lean, articulation, blade pitch, and drawbar or circle movement. Compatible with complex road designs, like crown sections, super elevations, and court bowls, it supports one-operator precision. With no need to remove or reinstall equipment, It increases productivity and safety. Experience fewer passes, better results. Unleash your blade's potential with mastless CAT Grade 3D. The spiral rebar fabrication process in the field begins with placing the steel frame onto the fabrication machine. A rebar is then hooked at one end of the rotating frame. As the machine operates, the rebar is continuously rolled around the frame to form a uniform spiral shape. Once the desired spiral length and diameter are achieved, the completed spiral rebar is carefully removed from the frame. This method is widely used on construction sites for creating reinforcement spirals for columns, piers, and other circular structural elements. When every second counts and space is limited, FirstGuard delivers the perfect solution. Measuring 28.75 inch to 29 inch when unfolded, FirstGuard ensures high visibility while maintaining a compact profile when stored. Folded, each unit measures just 33.5 inch x 5 inch x 1.5 inch, allowing for easy transport and storage. The carrying case holds 5 cones, fits easily in standard trunk space, and ensures smooth retrieval during emergencies or quick response operations. FirstGuard is the smart, space-saving solution for efficient traffic or hazard marking on the go. The RSM-045 cage welding machine by MBK is designed specifically for producing reinforcement cages for precast-driven piles, essential in deep and shallow foundation construction. Engineered for high reliability, ease of use, and stable performance, the RSM-045 suits rigorous daily operation in precast concrete plants. It features an advanced welding point control system, ensuring premium weld quality and production output of up to 750 linear meters per shift. With flexible dimensions, from 175 by 175 millimeters to 400 by 400 millimeters, and easy parameter adjustment via a touchscreen interface, the RSM-045 simplifies programming and saves welding data for efficient daily production. The BSM-190R cage welding machine by MBK is a fully automated solution for producing reinforcement cages used in concrete pipes and manholes. Designed for precision and efficiency, it supports cage lengths up to 7,000 millimeters in diameters from 220 to 5,200 millimeters, including round, oval, and complex shapes. Key features include an automatic longitudinal wire feeder, ALZM, and a winding wire change system, AWDW, that enable fast switching between wire diameters with minimal downtime. Advanced automation modules, such as the KFG removal and joining unit streamline handling and transfer to downstream machines. The system includes state-of-the-art software for production tracking, remote diagnostics, and efficient operation. The BSM-300R cage welding machine from MBK for the production of reinforcement cages for the manhole and concrete pipe industry. Equipped with the ALZB automatic longitudinal wire feed and KFG cage removal system, the machine enables efficient, high-precision production of round, oval, egg, and special-shaped cages. It supports cage diameters from 220 to 5,200 millimeters in lengths, up to 7,000 millimeters. Integration with DRA wire straightening and cutting units ensures smooth workflow with wire diameters from 4 to 20 millimeters. Optional full automation, buffer, and transfer modules provide seamless reinforcement handling to downstream equipment. The VSM-057S cage welding machine from MBK is engineered for manufacturing reinforcement cages for driven and bored piles, especially in challenging ground conditions. It supports the production of square, rectangular, round, and triangular cage geometries, with quick-change disc systems for efficient geometry switching. The VSM series guarantees high stability and reliability, capable of handling longitudinal wires from 8 to 25 mm and winding wires from 5 to 8 mm. With adaptable automation options like wire straightening, feeding, removal, and stacking systems, the Nairobi Expressway involves advanced engineering works including subgrade preparation, culvert installation, and launching 274 box girders. Bridge works progress steadily at Nyayo Stadium and NextGen Mall. The project integrates structural precision, ensuring durability and traffic flow efficiency along the elevated Mombasa Road section. The pipe bursting process using the Rody Inc. R8 pipe bursting machine is a trenchless method designed for replacing old or damaged pipelines with minimal surface disruption. This operation begins with excavating two small pits, an entry pit where the new pipe will be pulled from, and an exit pit where the bursting head is launched. First, the existing utility line is identified and exposed. Then, a high-strength cable is inserted through the old pipe, connecting the R8 bursting head to the hydraulic puller on the opposite end. The R8's heavy-duty hydraulic power pack is positioned near the entry pit and is connected to the pulling unit. Once engaged, the R8 machine begins pulling the bursting head through the old pipe. The bursting head is a conical steel tool that fractures the old pipe while simultaneously pulling in the new HDPE pipe behind it. As the head advances, the old pipe is broken and displaced into the surrounding soil, while the new pipe is laid in its place. The R8 is known for its compact design and powerful performance, capable of replacing pipes ranging from 4 to 8 inches in diameter. The system features automatic rod feed and retrieval, efficient bursting capabilities, and compatibility with a variety of ground conditions.
You're about 1.5 feet. There you go. There you go. You're in the pipe. There.
Once the bursting is complete and the new pipe is fully pulled into place, the ends are trimmed and reconnected to the utility system. The launch and receiving pits are then backfilled, completing the operation with minimal impact to the surface environment. Parakeet, the motion-activated, audible information device designed to guide pedestrians with clear, pre-recorded messages. Mounted on standard traffic control equipment, it delivers up to 60 seconds of instructions through a built-in speaker. With a 15-foot detection range, Parakeet activates only when pedestrians approach, enhancing safety and accessibility. Imagine crossing the road while looking at your phone speed, not knowing that danger is just a few feet away. Borough North has developed Smart Tactile Paving, a smart pavement solution with integrated LED lights, flashing green when it's safe to cross and red when it's time to stop. The design aims to reduce accidents, with over 3,500 pedestrians seriously injured each year in Australia.